So I thought this would be an interesting demonstration in overloading by overloading the POW function in the C++ standard library. We looked at the POW function earlier in the semester. We use it to raise a base to a power. And so, for example, here 81 would be printed at the console. So, let me just type in, this is the POW function from the library, and when I open a paren, 7 versions of POW pop up in the sign. So it actually is already pretty heavily overloaded, but we can overload that even further by adding our own POW function. So that's what I've done up at the top here. There is no version of POW in the standard library that accepts 2 integers, so I've overloaded this one to accept 2 integers. And so that again, overloaded functions, same name, different parameter lists. So we have 2 integer parameters. I've chosen the return type as a long int, like the 8-byte integer, because these numbers are going to grow exponentially. So I went for the biggest possible int I could find. And one thing I should mention, I mentioned in another video that the parameters of a function and the return type of a function have no bearing on each other. Okay, one doesn't influence the other or determine the other, so keep those separate in your mind. Another thing I should say is that the return type of the function has no bearing whatsoever on whether or not the functions are overloaded. So if you're looking at 2 function prototypes and you're like, are these overloaded? Fall back on those same simple criteria, same name, different parameter lists. Don't even think about this part, the return type. Okay, so in any case, there is my prototype for the overloaded POW. This is the definition down at the bottom. I just hand-coded a function that's going to take in a number as the base and raise it to the exponent. And I really did that by doing a loop that'll run exponent number of times. Okay, and so just multiplying, I have like a result in long int that's going to be sent back to main or returned by my POW function. That result equals, every time through the loop, it's going to be whatever's already in there times the base. And so I'm multiplying the base times itself exponent number of times, which is raising a base to a power. And then ultimately I'll return that result back to main. And let's take a look at the function call. There it is. Again, this is a function that will return a result. So I'm not going to have the function just sitting there on its own line. I am going to use it as part of a larger code statement, which is what I'm doing here. So we make sure we capture that value in some way. In this case, we're sending it to the output stream. That's it.